So welcome back to lecture once again, guys. Now in this lecture I'm going to talk about one very important term called as kurtosis inside a statistics. So let's try to understand what is kurtosis. Obviously with the help of examples, formula and everything, I'm going to talk about kurtosis, plus I'll try to even talk about that where you are supposed to use or what is the actual use case of a kurtosis. So let me share my screen and let's start talking about this term called as kurtosis. In stats, yeah, in stats. So guys, so far we have been talking about a normal distribution curve, and this is how this normal distribution curve looks like, right? And if the data is skewed, so obviously I will be able to see this kind of a curve, or I will end up getting this kind of a curve. So maybe a positive skewness, or I can say a right is skewed, right? So we have a more higher side of the data, uh, a skewed one, top higher side of the data, and then this is the negative one, right? Negatively skewed, or you can say it's a left hand side. Yeah, it's a left hand side, it's a negative one. So based on these kind of a shapes, so obviously I can say that there is an outlier inside a data, and again, so I can clearly claim that okay, on which side there is a high, like a high side, or there is a low side, we have a skewness into a data set. Just by looking at this, I will be able to talk about, I will be able to say this one easily, right? Easily. But there is a term you will be able to find out, and that term is called as kurtosis that we are talking as of now. So kurtosis is also a normal distribution kind of a curve, right? We try to observe that curve, and based on the observation of this bell curve, by the way, so we try to identify, we try to conclude something about a data set. What we are going to conclude will come to that particular point. But before that, I believe you should understand that kurtosis is not something which is going to talk about a direction of the data like this one, or like this one, that okay, in which direction my data set is skewed. Yeah, so it is not going to talk about that okay, in left hand side direction or in the right hand side direction my data set is skewed. And kurtosis, as we are able to find out this left skewness, right skewness, even with the help of mean, median and mode, but it is not going to follow, or it is not going to indicate a central tendency, or just by using a central tendency you will not be able to do the calculation. So this is something which kurtosis is not, right? So technically kurtosis is not going to talk about the skewness direction of the data set. Then what kurtosis is going to talk about? So let me show you that part. So here what we are going to do is that we are going to draw a curve. Yeah, so 1, and then a 2, and then a 3. Yes. So all these curve look like basically a normal distribution curve, right? Now, I told you that kurtosis is never going to talk about basically a direction of the skewness. But what kurtosis is going to talk about? So basically kurtosis is going to talk about a shape of the tail, and the peak, right? A peak of the distribution. And what kind of observation I will be able to find out? Just by looking into a shape of the tail and the peak. Yeah, so shape of the tail and the peak, what kind of observation I will be able to get? So here I'll come to that particular point, but this one I'm going to name it as a leptokurtic. Yes, the white one I'm going to name it as, or I can say I'm going to label it as a mesokurtic, and the yellow one I'm going to name it as a platykurtic. Fine. So we have a leptokurtic, we have a mesokurtic, and we have basically a platykurtic. Yes, so we have all three curve over here. Now, so let me put some values over here. So k should be greater than 3. A critic value should be greater than 3. For this one, so k should be, for meso, k should be equal to 3, and for platy, so k should be lesser than 3. And now you have a lot of question that from where we are getting this k value, and how we can try to do a math for k value. What is the meaning of lepto? What is the meaning of meso? What is the meaning of platy? Yeah, so a lot of questions, right? A lot of questions now has arisen, and the most important question is what I'm going to do with this. What kind of observation I will be able to find out? That's a major question for all of us. Yes, even for me when I was like a year back when I was trying to study the same thing. Yeah. So here, so lepto, meso and platy. So as Kurtosis always talks about a shape of tail and the peak, by the way, yes, shape of the tail and the peak. So whenever I'm talking about a leptokurtic, yes, whenever I'm talking about the leptokurtic, so it's going to be a heavy tailed. Heavy tailed means like this way. It is going to spread. Yeah. So we'll be having majority of data concentrated over here, but we'll be having a heavy tail. Yeah, this is something called as leptokurtic. So it will be having a heavy tail and tall and sharp. Yes, so tall and sharp, it will be having a peak. As you can see, it is having a most tallest and sharpest peak over here. And what it is going to represent? So it is going to basically represent a most chances of a extreme outlier. Yeah, so it is going to represent that, okay, so we are having a extreme outlier with respect to this data. So whatever data which I have used to represent this entire leptokurtic, this is what it is going to talk about. So generally we rely on this mathematical calculation, and we try to find out basically k value based on the formula. And if k value is greater than 3, it simply means that heavy tail, right? Heavy tail and tall and sharp peak, tall and sharp peak. And this is called as basically leptokurtic. So whatever data that will be having k is greater than 3, we can try to label it as a leptokurtic, as simple as that. And it says that there is a extreme outlier. Extreme outlier. So this is what it always talks about. Now the white one, right? A meso. So wherever we have k is equal to 3, it looks like it will be having a normal tail, and it will be having a moderated peak, and it says that it is a actual normal distribution. So ND I'm talking about. So this is something where there is no outlier at all. Yeah. And here, so the yellow one, which I'm labeling as a platy, so you can say that it will be having a light tail, not a heavy one. So it will be touching this surface very soon, kind of a tail. You will be able to find out. So dispersing its tail with the surface, you will be able to find out. So it will be having a light tail and flat and broad peak shape. So this peak is going to be what? So it's going to be flat and broad. Flat and broad, basically peak, you will be able to find out. So more spread out area you will be able to find out on a peak, by the way. And this is called as platykurtic. Calculation wise, so whenever you are going to do a math, so k value should be lesser than 3. Now that's completely fine theoretically, right? That's completely fine. That okay, so if I have a lepto, so in that case obviously we have an extreme outlier. If we have basically a platy, so in that case we will be having obviously a few outliers, right? A more spread data, you can say. Few outliers, more spread data. Yeah, this is what it means. So fewer outliers and more spread data I will be able to find out in case of a platy. Yeah, in case of a platy. Now the question is that how I will be able to do a math, how I'm going to do a calculation, by the way. So to do a calculation for a kurtosis, where you will be able to see a value of like a k. So kurtosis, or you can say to find out a value of k, the formula is going to be n into n plus 1 divided by n minus 1 n minus 2, n minus 3, summation of basically a data xi minus mean average divided by standard deviation to the power 4 minus 3 into n minus 1 square divided by n minus 2, n minus 3. So where n is what? So n is nothing but number of data points. So this formula is technically going to give you the value of k. And we know that if k is lesser than 3, then in that case, what is the meaning of it? If k is equal to 3, then what is the meaning of it? And if k is greater than 3, then what is a meaning of this one? Xi is nothing but, you can say, a data point, data itself. X bar is nothing but a mean or average. S is nothing but it's a standard deviation. Standard deviation. Okay, fine. So this is what it means, and this is how I will be able to calculate a kurtosis. It's also called as Pearson definition for the kurtosis. So whenever you are going to do little bit of research, so in a SciPy library, you will be able to find out a simplified version of this kurtosis. But yeah, this is basically called as population kurtosis, and it's coming from a Pearson definition. So this is the actual formula which has been used to find out that whether my data set is having a heavy tail or tall sharp peak, or maybe the lighter one, or maybe the normal one. And based on that, I will be able to find out the value of k is equals to 3. Now, all of these things are completely fine. What is the use of it? Yes, the major question is, what is the use of it? I'll tell you that there are a lot of use you will be able to find out in lot of domain. The very first one is a finance and risk management. Finance and risk management. You will be able to find out a lot of use cases. So basically, to access a risk of the extreme loss and the spike, right? So extreme loss and spike. So we try to use this kurtosis. For example, if the stock is high kurtosis, so it simply means that, so stock is having a, let's suppose there is a stock and the stock is having a higher kurtosis value. Higher kurtosis value means what? So K must be above 3. Yeah, this is what I'm talking about. So let's suppose your data set is showing a leptokurtic in nature. Now, if it is showing a leptokurtic in nature or higher kurtosis, so it will be having a more outlier events, and it simply means that it will be a riskier for a investment. Simple. So high kurtosis means more riskier for a investment because it will be having a more outlier event. So this is where, this is one of the place you will be able to find out in a day-to-day like a life. You will be able to find out this usefulness of the kurtosis. So if it is showing a nature of lepto, which is like higher value of K, more than 3. So in that case, it's a riskiest stock and you should not do the investment in that one. Now, so we try to use this one in quality control and manufacturing. So quality control and manufacturing. So even over here, if we have a high kurtosis, right? So we can say that there will be a multiple outliers or there will be a multiple failure. So there is a multiple issue in my quality or there is a multiple issues in my manufacturing. As simple as that, right? So it all looks fine, but yes, your kurtosis is telling you a different story. So over there, in a quality control, we can try to use it. In case of statistical modeling and hypothesis testing, so again, we try to use a kurtosis to check a normal distribution of the data, right? Kurtosis plus isUnits, we can try to combine it and then we can try to check it. Machine learning and feature engineering. So again, we can try to use a kurtosis. If value of kurtosis is very, very high, it's not good for me. Medical and scientific research, again, I can try to use it. So whether it's a statistical modeling, whether it's a machine learning, whether it's a medical and a research field, a simple meaning is wherever data is involved. wherever we are trying to do a data analysis. Obviously, we have to talk about the skewness and we have to talk about the kurtosis, and higher value of kurtosis, which will fall under a lepto, is not acceptable. Very, very lower is also not acceptable. For example, a platy. So platy is again not an acceptable one. If it is in a meso, we will try to accept it. And if it is not available in a meso criteria, then we can try to maybe bring it, right? We will try to bring it inside a meso criteria. But yes, this is all about a kurtosis, and hope all of you are able to find out, all of you are able to understand all three kind of a lepto, meso, and a platy. Kurtosis, now you are aware about the formula. Anyhow, you are not supposed to use the formula again and again. You don't have to remember the formula, because we are going to use a library to find out these things. So there is a library, SciPy stats kurtosis, where you will be able to find out a direct formula, and you just have to pass your whole data. It will be able to do a math for you. Yeah. So anyhow, mathematically, it's not a very complex formula. It's a very, very simple one, as you can see. But yeah, little bit a lengthy one, and that you don't have to do a calculation. As simple as that. But yes, if I'll talk about a concept about the kurtosis, it's very much important. It's important in terms of identifying the very, very high outliers. So where k is greater than 3. And again, in case of a domain, it may create a risk for you. So with that, thank you so much, everyone. Take care and see you again in my upcoming lectures.